Good day. Today we'll be discussing food security with regard to a specific crop species and ecological niche modeling and how important it is with regard to food security and understanding it. So with regard to food security, today it seems to be quite an environmental problem. There is so much food insecurity in the world and lots of people are actually even dying from starvation, as nutritious food is not really available. People have succumbed to cheaper foods, processed foods, because of this unavailability. Therefore, we'll be looking at niche modeling. This has to do with the potential distribution of species, specifically with climates and where certain crops can be grown in order to increase food security. We will then analyze this. We will see how geographic space can increase food security. The crop that I'll be discussing is asparagus, with the scientific name of Asparagus Officinalis, in the specific region of Western Europe, specifically in around Romania, Belarus, and around those areas. How data was obtained. So I received my climate data from the DEVA website, the future and current climate, and I received my species data from GBIF. GBIF stands for the Global Biodiversity Information Facility. It's an international network and research infrastructure founded by the world's governments and aimed at providing everyone, everywhere, open access to data about all types of life on Earth. And DEVA is a geographic information system. It's a free computer program for mapping and geographic data analysis. With DEVA, you can make maps of the world or of a small area. DEVA was specifically useful to me and to niche modeling, as it allows you to take recorded data sets to create into shapefiles, to create an actual visual about the recording of the data, to make it easier to understand, as the visual representation seems to always do so. Asparagus is really interesting in that it has a long history going back as far as the 1st century. There tend to be records of it growing in ancient Greece and Rome. They offered it up to the gods in their rituals, apparently. As with all the vegetables, the first asparagus was discovered in the wild. Current climate distributions. This figure shows the current global potential of asparagus to grow with regard to climate favorability. As we can see according to this map, that suitability tends to only be quite excellent on top of Africa in Western Europe. According to this regional map, we can now identify where exactly it is. The most excellent favorability of asparagus to grow tends to be in France, Belgium, and Germany, with surrounding areas being very high, then medium, and then low. Bioclimb. Currently, bioclimb is an envelope-style method which uses only occurrence data to define a multidimensional environmental space in which a species can occur. As we can see in this map, there is an area with very high suitability but not growing there. That tends to be in Europe, mostly Bulgaria, Serbia, and Hungary, as well as Romania. It's very high there, but no occurrences. Here it's more clear in the regional map. It's safe to say that it's mostly in Romania, Serbia, and Bulgaria. This is even evident when we go to true or false. As we can see, the regional map doesn't really have much space for favorability of asparagus growth. There's only a small portion in South America, North America, and Australia, and the largest being in Europe. This is the global bioclimate, considering only where it is and where it's not suitable for asparagus growth. Figure 6. The regional bioclimate, considering only where it is and where it's not suitable for asparagus growth. As we can see, there is an area in which asparagus occurs, but there's also a large area in which it doesn't occur. These tend to be Romania, Hungary, and the previous places that I've mentioned. So considering that this is all the current data that I've discussed, let's see what the future holds with regard to asparagus growth. Future climate distributions. The future global potential for asparagus growth with regard to favorability. Bear in mind that this map only takes the environmental envelope into account. It is clear from the current distributions that there is more of a surface area that is suitable for asparagus growth. It is clear that Western Europe is still the most favorable area. The countries with the most excellent favorability, as well as very high suitability, is France, Ukraine, Belarus, and Lithuania. This figure is the future regional potential for asparagus growth with regard to favorability. It is clear that it is France, Belarus, Lithuania, and the Ukraine which has the most potential growth for asparagus. Now we will be looking at eco-crop modeling. Eco-crop identifies a plant species with key climate and soil requirements that match the data that was entered in DIVA GIS. We will be looking at the present versus the future. The most noticeable difference from present to future is the increase in area for asparagus growth. In the present map, a portion of not suited area near France becomes marginal and very marginal in the future eco-crop model, instead of being not suitable at all in figure 10 of the present eco-crop model. We will now use the plot analysis to interpret and analyze our founded data. The first aspect that we will be looking at is potential. This considers the species' potential to either increase its role as a food plant for significant investment to be made to establish economically productive cultivation now, and given the anticipated climate changes. With proper care in suitable conditions, asparagus crowns can last up to 15 to 25 years. Asparagus also favors sandy loam soil with a pH of over 6. The ideal temperature for asparagus to grow is approximately 20 degrees Celsius. They thrive in full sunlight and tend to tolerate some shadow. These plants don't really like too much water. Their roots will eventually rot if there's too much water in the soil. Next, we will be discussing limitations. Asparagus only grows sufficiently in June or July in Western Europe, as the temperature is right with minimal precipitation, which is favorable, as mentioned earlier, for asparagus plants. The next limitation may be distance. Asparagus grown in Europe may not be exported throughout the world, as the demand for the crop is relatively low. Next, lack of growth in many areas. As the demand is low, countries would not put much effort into farming this crop, as it requires much effort to induce growth in favorable conditions, as well as only Western Europe has the best soil for sufficient growth of the crop. Now we will be looking at opportunities. Asparagus is tasty and nutritious. It contains vitamins A, C, E, K, and B6, and minerals such as folate, iron, copper, calcium, protein, and fiber, making it a good addition to any meal. Next, location. It has a major advantage regarding where it is grown. It's mostly located in France near the United Kingdom, Germany, and various other wealthy countries who would be willing to buy this delicious crop, as it is used in various European dishes. Because the main consumers of this crop may be from such countries, it has another advantage regarding distance. It does not need to be exported by air or water masses, it will be sufficient by rail or roadways. Therefore, trucks and trains are ideal. They also tend to be much cheaper. Now we'll be doing the last part of my analysis, threats. Asparagus officinalis has invasive potential. Therefore, it may lead to overpopulation of the crop. There may be potential economic loss, as there is a risk of overproduction that could push production costs higher than economic returns. I have now finished my plot analysis and will be going to the conclusion. So, asparagus is not necessarily impacted by climate change, and my maps indicate that there will be increased areas for favorable potential for asparagus growth in 2050. Also, majority of asparagus growth occurs in Western Europe, mostly in France. There are my references. This is the end of presentation. Thank you very much.